Okay, so they tell us that the units, this is a square and this side length is 10 units. Okay, and they tell us this is x and this is also squared, meaning these lengths are all equal. So if this is x, you can see that this would also have to be x. Okay, because of the fact that, right, if this is x, let's call that y. Okay, let's call that y. So this is a triangle with x and y. And because of the fact that this is a square, they all have to have xy, xy. They have to be the same congruent triangles. Okay, so this is xy. But you know that x plus y is 10, which means y, we can just write it as 10 minus x. It says to determine the area of the inscribed square as a function of x. So let's call this S squared by Pythagorean theorem must equal to x squared plus y squared. Now y is 10 minus x. Okay. So then S must equal to the square root of x squared plus 10 minus x squared. What is the area of the squared? Well, area is s squared. So we can just copy and paste this part right here. The area is x squared plus 10 minus x squared. Second part, part B, determine the domain and range. Okay, so the first thing we actually have to do is expand this out, because we're going to get a quadratic, which is a parabola. X squared plus 100 minus 20x plus x squared. Combine the 2x squared, you get 2x squared minus 20x plus 100. Let's factor out a 2 from the first two terms. Okay, I'm going to complete the square here. So I need x squared minus 10x, and this divided by 2, which is 5 squared, is 25. Okay, and I have to subtract the 25, but that has to be multiplied by this 2, because this, if you open the bracket, this 25 would have been multiplied by 2. Okay, so we're almost done. 2x minus 5 squared, this is minus 50, plus 100, so it's plus 50. It's a parabola. So the domain, right, a parabola looks like this. And this one in particular looks like this, 5 and 50. Roughly looks like this. So x is everything. Okay. The range, however, it's only from starting from 50 and up. So y is, right, or you can say actually not y, in this case it's the area. Area is such that area is greater than or equal to 50. Okay, area can belong to a set of all real numbers. That's the range. Okay, and then, so now determine that, this is part B. It says C, determine the perimeter of the inscribed. Okay. The perimeter is clearly 4s. So here's our s. So it's going to be 4 times by this square root expression. So what is a domain? Now, a domain is a little bit more tricky. Now let me put the simplified version of this in the completed square form, which is right here. Okay. Okay, so it's 2x minus 5 squared plus 50. Now domain is actually everything, because of the fact that what we have inside, we already determined it's always greater than or equal to 50, meaning we're never going to be square rooting a negative value. Doesn't matter what I plug in for x. Okay, so that means the domain for this perimeter function is also going to be everything, because we're allowed to plug in anything in, and we're okay. Okay, we don't do any illegal operation. Now the range is, what is the lowest value of this inside function? We already determined that was 50. So the smallest perimeter is going to be 4 times root of 50, which is 4 times, right, root of 25 times by 2. So 4 times by 5. So it's 20 root 2. That's the smallest value of the perimeter. But it's only going to get bigger than that. So therefore, the range of the perimeter is perimeter such that perimeter is greater than or equal to 20 root 2. Okay, 20 root 2, where perimeter can be belongs to a set of real numbers.